All right, in this video, I'm going to be, let me get my face up here. I'm going to be working some matrix multiplication problems, really is what it is. But this is linear algebra homework 1.3. Okay, so let's get out here. I should have found myself a pen before I started recording, but I'm sure I've got one nearby. All right. So we're going to use the matrices above for numbers 1 through 5, and we're going to find a plus b. Okay, so that's starting off nice and easy. A plus b is going to be 2, 2, 0, 6. Okay, what's next? Negative 3c. That's going to be, negative 3c is going to be 6, negative 9, negative 3, negative 3. All right, and then b plus 3c. Okay, so I'm just going to go entry by entry. B plus 3c is going to be negative 6. B plus 3c is going to be 8. B plus 3c. B plus 3c. And there you can see it. Okay. No, I'm not zoomed in too far. I just need to get everything set up right. All right. Yeah, that's a little better. Okay, that was number 1. Number 2, find a matrix D for which A plus 2B plus 2D equals 3B. Okay, I can do that. Okay, so they're saying A 2B plus 2D equals 3B? What? Okay, whatever. Copy this one out of the textbook, so I mean, I don't know. Why would you have B on both sides of the equation? Doesn't make any sense. Anyway, not worried about it. I'm solving for a matrix D. So I'm just going to solve for D just like this is regular algebra, right? So I'm going to say that D is going to be 3B minus 2B is 1B minus A multiplied by half. Okay, so I have not done B minus A yet, but I can probably do B minus A. 0 minus 2 divided by 2 is negative 1. Okay, negative 1 minus 1, B minus A, is negative 2 divided by 2 is negative 1. Okay, B minus A divided by 2, that's going to be 0. B minus A, okay, again, 0. Okay, that's the matrix D. Okay. Number 3, AR, BU, and 3 times S plus 3T. All right, can't wait to do that. Okay, just try this upside down. Say AR is going to be 2, 1, 1, 3 times R is 1, 0. Oh, that'll be easy enough. Okay, first row, first column is 2 plus 0, and then down here it'll be 1 plus 0. Okay, for part B, that's BU. So I'm going to just copy B, 0, negative 1, 1, 3, times U, which is negative 4, 6. And let's see, that's going to be 0 minus 6 and negative 4 plus 18. Okay, that's 3B. And 3C is going to be C times S plus 3T. Okay, I'm going to just figure out what S plus 3T is. So S plus 3T, you can't even see that, is going to be 2 plus 3 is 5. And negative 3 plus 12 is going to be 9. Okay, so it's 5, 9. Okay, S plus 3T. Now, if I want to multiply C by that, that's going to be, okay, let me make sure we're shot. 2, 1, 3, 1 times 5, 9 is going to be, we got negative 10 plus 18 plus 9. Okay. And yeah, that was 3C. Okay. Number 4, A, B, B, A, and C, Z. Okay, all of these are going to be defined. Oh, C, Z, that one's going to be pretty easy. But that's what we're going to involve some arithmetic. So let me just out the way. AB, BA, and CZ. Okay, so AB oh, right, and that's going to be, I know that's going to be a 2 by 2 by 2 by 2. That's going to give me back a 2 by 2, so I'm going to say 0 plus 1, negative 2 plus 3, 0 plus 3, and negative 1 plus 9. Okay, that's AB. BA, oh yeah, okay, so I definitely assigned this problem so that you could see for yourself how matrix multiplication does not commute. Okay, this is 0 minus 1. Going to the right, I've got 0 minus 3. Okay, 2 plus 3, and 1 plus 9. Okay, very different. They're not like inverses of each other either, so just be aware of that. They don't really have any relationship. Okay, AB, BA, and CZ. Okay, if you don't believe me, I'm going to ask you to just go through and check it yourself. But you multiply by a zero matrix, you get a zero matrix back, provided that their dimensions are appropriately matched. CZ, it's going to be 0, 0. And 0, 0, 0, 0. And if you don't believe me, definitely just go do the multiplication yourself. Okay, that was number 4. Number 5, I'm going to name a new sheet. R times U transpose, that's going to be 1, 0 multiplying on U transpose is negative 4 and 6 going to the right. And now this is a little tough, but first row by first column is negative 4. And also, hold on, so if I've got R times U transpose, okay, R is a 2 by 1, U transpose is a 1 by 2, meaning I'm going to be left with a 2 by 2 matrix at the end. And that's something that we call the outer product, but that's a different discussion. For first row, second column is going to be 6. Okay. Second row, first column, that's 0. Second row, second column, also 0. Okay. That's 5A. For part B, I'm interested in doing the opposite. I'm interested in doing U transpose, right? U transpose multiplied by R. So negative 4 and 6 multiplied by 1, 0. And that's going to end up being just a 1 by 1 matrix that has negative 4 in it. And an interesting question from class was like, is there a difference between a 1 by 1 matrix and a scalar? And it does feel to me like there is. I mean, I'm not entirely sure what we need a 1 by 1 matrix for. But a 1 by 1 matrix is going to be limited in the things that it can multiply other matrices by, whereas a scalar, not limited. You can distribute in a scalar wherever. All right. And that was number 5. Okay, so I'm going to scoop that up. And I'll start doing number 6 here. Okay, A is 2 by 3 and B is 3 by 4, so 6A. 2 by 3 and B is 3 by 4. Okay, yes is a 2 by 4 matrix. Okay, let's see, BA is 3, 4 by 2, 3, undefined. Okay, AB and BA, where A is 2 by 3 and B is 2 by 4. Okay, D and E. BA is B is 2 by 4, A is 2 by 3. That also doesn't exist. Okay. Yeah, you would need to transpose one of these in order for these products to be defined. Okay, AB and BA, where A is 3 by 7 and B is 6 by 3. Okay, so I think BA is going to be defined. BA is 6 by 3 by 3 by 7. Yeah, is a 6 by 7 matrix, and AB doesn't exist. Okay, the only way that AB and BA will both be defined is if they're both square matrices. Okay, for a given like fixed dimensions of A and B. All right, AB and BA, A is 2 by 3, B is 3 by 2. Oh, what I just said was a complete lie. I did not think of this. Okay, I was thinking of something else. AB is 2, 3 by 3 by 2. Yeah, and I just saw, we're multiplying R by U transpose both ways, and those weren't square matrices. That was a silly thing to say. Okay, so this is a 2 by 2 matrix, and BA is going to be I would think, yeah, that's going to be a 3 by 3 matrix. Okay, E is going to be A is 3 by 3, B is 3 by 1. The resulting matrix will be 3 by 1. And then BA, B is 3 by 1, A is 3 by 3. This does not exist. This is undefined. A, oh, F and G. All right. Maybe I'll come up here. 6F is going to be, all right, A times BC, where A is 2 by 3, B is 3 by 5, and C is 5 by 4. Okay, so my resulting on BC will be a 3 by 4. BC is a 3 by 4 matrix. So I'll multiply 2 by 3 by 3 by 4, and I'm going to get a 2 by 4 matrix. That was an interesting question. Oh, wait, but I also want AB times C. Okay, and A is 2 by 3, B is 3 by 5, and C is 5 by 4, which is a 2 by 5 by a 5 by 4. Also an R2 by 4. But I'm just going to tell you that matrix multiplication does associate, so that should not be surprising. And then 6G is going to be AB and BA. Okay, A is 1 by 4, B is 4 by 1. That's a 1 by 1 matrix. BA, I think it's going to be a 4 by 4 matrix, so it's 4, 1, yeah, 1, 4. Okay, that's number 6. All right, and number 7, this is the one that everyone was asking me about at the beginning of class when you came in, because I'm not get these solutions recorded in a timely manner. You can zoom in a little bit. Yeah, how about that? Okay, so we're going to find a matrix B for which C is equal to A times B. Okay, so I'm going to say that 2, 6, 3, 6 is equal to 1, 1, 3, 4 times B1, B2, B3, B4. Okay? And then I'm going to actually do this multiplication. So I'm going to say this is a 2 by 2 matrix, so it will be B1 plus 3B3. Okay, to the right I'll have B2 plus 3B4. Okay, down below I'll have B1 plus 4B3. And then to the right, I've got B2 plus 4. All right, now we know that because of this, I need, I'm just getting a pen, red pen. Because of these numbers here, I need this to be equal to 2, this to be equal to 3, and both of these to equal 6. And how I solved it, I was like, wait a second. If these are both equal to 6, then these need to both be the same. And that actually is going to really help. So I'm going to say that B2 plus 3B4 is equal to B2 plus 4B4. And it's like, that sounds suspicious. So I'm going to subtract B2 from both sides. I'm going to get 3B4 is equal to 4 times B4. And the only way you can take a number and multiply it by 3 and have it be the same as taking that number and multiplying it by 4 is if that number is 0. So I'm just going to conclude that B4 is 0. And then, well, B2 is 6. Okay. And then we can do some work to find the other ones. Okay, so B1 plus 4B3 equals 3. And B1 plus 3B3 equals 2. So I'm going to subtract the second equation from the first. 4 minus 3 is 1b3 equals 3 minus 2 is 1. It kind of looks like a 4, but it was a 2 with a parenthesis around it. All right, so b3 equals 1, and that would mean that something plus 4 equals 3, b1 equals negative 1. So my matrix that I've been hoping to find is b equals negative 1, 6, 1, 0. You can't see that, but that's what I meant. Okay, and that's going to be all for this video because I do have more matrix multiplication practice, but it's a CUDA worksheet, so like I'm pretty sure that it's 4 pages. The first 2 are problems and the second 2 are solutions, and that's just drill, and you don't need to watch me do drill repetition of matrix multiplication. You need to just do it yourself. Okay, so that'll be all for this video.